Hi, we are from At Home Tuition. In this video, we are going to see few examples on finding squares and square roots of a given number. Our first question is 2352 a perfect square? If not, find the smallest multiple of 2352, which is a perfect square. Find the square root of the new number. So, solution. So, first let's see the prime factorization of 2352. So, for prime factorization, first we are dividing the 2352 by 2. We are getting 1176. Again, we are dividing it by 2. We are getting 588. Again, we are dividing it by 2. We are getting 294. Again, we are dividing it by 2. We are getting 147. This 147 cannot be divided by 2. So, we are dividing it by 3. We will get 49. So, 49 you can divide it by 7. So, 7 you will get 7 as the answer. So, now we are writing 2352 in the factored form. That is 2 times 2, 2 times 2, 3, 7 times 7. So, if you see here, the prime factor 3 has no pair. So, 2352 is not a perfect square. Okay. So, if we get 3 pair for 3, then the number will become a perfect square. So, what we are doing, we are multiplying through 1352 by 3 to get a perfect square number. So, now here 3 got a pair, so it will become a perfect square number. If you multiply 2352 with 3, you will get 7056, so which is a perfect square. Thus, so we need the smallest number 3 to be multiplied with 2352. So, you will get the answer as 7056, so which is a perfect square number. So, now we will see square root of 7056. So, now you have to take one number from each pair. So, here for 2 is a pair, so I am writing 2. The next 2 is a pair, I am writing 2. Next 3 is a pair, so I am writing 3. Next 7 is a pair, I am writing it once. So, 2 into 2 into 3 into 7, so which is nothing but 84. So, square root of 7056 is 84. Thus, we can conclude that 2352 is not a perfect square. If 3 is multiplied to 2352, then you will get 7056, which is a perfect square number. So, the square root of 7056 is 84. Next question is, find the smallest number by which 9408 must be divided so that the quotient is a perfect square. Find the square root of the quotient. Solution. So, first let's find the prime factorization of the number 9408. So, for prime factorization, first we are dividing 9408 by 2. So, you will get 4704, which is further divided by 2, you will get 2352. Since it's an even number, again we are dividing it by 2. So, we will get 1176. So, which is again divided by 2, you will get 588, which is again divided by 2, you will get 294. Which is further divided by 2, we will get 147. So, 147 is an odd number. So, we are dividing it by 3. So, you will get 49. So, 49 you can divide it by 7, you will get 7. So, further 7 you will get 1. So, now we are writing this 9408 in the factored form. So, we are writing it in pairs 2 into 2, 2 into 2, 2 into 2. Then we are writing this 3 into 7 into 7. Look here, 3 is a single number which doesn't have the pair. So, as the prime factor 3 has no pair, if we divide 9408 by the factor 3, then we will get 3136. So, now 3136 can be written in the prime factorization as 2 into 2, 2 into 2, 2 into 2 into 7 into 7. So, now 3136 is a perfect square number because all the factors occurs in pairs. So, therefore, the required smallest number is 3 to make the given number 9408 to be reduced by 3 and to form a perfect square number 3136. So, the square root of 3136 is, we are writing it in one time. We have in pair, so we have to write it once. So, 2 into 2 into 2 into 7, so which is 56. Thus, we can say that 3 is the smallest number by which 9408 must be divided so that the quotient is 3136, which is a perfect square number, and the square root of the quotient 3136 is 56. Next question is, find the smallest square number which is divisible by each of the numbers 6, 9 and 15. So, now this has to be done in 2 steps. First step, find the smallest common multiple, and then the second step, find the square number needed. So to find the smallest common multiple, we are taking the LCM of 6, 9 and 15. So if you take LCM, first we are dividing it by 2, so you will get 3, 9 and 15. Then next step we are dividing it by 3, you will get 1, 3 and 5. Next step we are dividing it by 3, you will get 1, 1 and 5. Next 5 we will get 1, 1, 1. So the LCM of 6, 9 and 15 is 2 into 3 into 3 into 5. So which is 90. Okay, the smallest common multiple is 90. So now we are going to find the prime factorization for 90. So 90, first we are dividing it by 2. To find the prime factorization, we will get 45. 45 we are dividing it by 3, you will get 15. 15 dividing by 3, we will get 5. 5 divided by 5, we will get 1. So now the prime factorization of 90 is, the prime factors are 2 into 3 into 3 into 5. So we see that the prime factors 2 and 5 are not in pairs. Therefore 90 is not a perfect square. So in order to get a perfect square, each factor of 90 must be paired. Okay, so we need to make pair of 2 and 5. That is, you have to multiply again with 2 and 5. That is 2 into 5, which is 10. So the required square number is 90 into 10, which is 900. So thus 900 is the smallest square number which is divisible by each of the numbers 6, 9 and 15. Next question is, what could be the possible ones digits of the square root of each of the following numbers? So the first number given is 9801. We know that from the properties of square number, if a number has 1, that is 1 into 1, 1, or 9, that is 9 into 9, if you get, you will get 81. As its ones digit, then the square number will end with 1 as its ones digit. So here given the square number, which is 9801, which ends with 1 in the ones digit. So the square root can have either 1 or 9 as its ones digit. So thus the possible values of ones digits of the square root of 9801 are 1 or 9. Next question given is 99,856. So here we are using the same property of square number. So if a number has 4 or 6 in its ones digit, then the square number will end with 6, because 4 into 4 16, which has 6, and 6 into 6 36, which has 6 in its ones digit. So here the square number ends with 6 as its ones digit. So its square root can have either 4 or 6 as its ones digit. So thus the possible value of ones digits of the square root of 99,856 are 4 or 6. Okay, so the next number given is 9,98,001. So now again we are using the property of square number. We know that if a number ends with 1 or 9 as its ones digit, then the square number will end with 1 as its ones digit. So here the given is square number. So it ends with 1 in its ones digit. So the square root can have either 1 or 9. So the possible values of ones digit of the square root of the given number may be 1 or 9. So the next question given is ends with 5. So we'll again you are using the properties of a square number. We know that if a square number has end with 5 its ones digit, then the number will also have 5 in its ones digit, because 5 times 5 is 25. So here the square number ends with 5 in its ones digit. So the square root can have 5 as its ones digit. So the possible value of ones digits of the given square number is 5. Hope you have understood all the questions well. Thank you for watching the video.